Hello, hello. My name is SFlorauna, and this is my presentation for my relief package drone for ECE216. So first is the overview. Uh, Pretty much we had to design a delivery drone for relief operations for stuff like food, clothing, shelter, medical supplies, etc. The parameters uh, are listed, but I will summarize and add my own thoughts. So must be capable of remote or autonomous travel, so needs a, you know, brain to be able to control from far away. Um, Units are the MMGS. I am a team of one, so I needed 10 unique parts for my project. The drivetrain, the mechanism to secure the package, one motor for propulsion, one for steering, and I did have one for steering, one motor for powering the delivery mechanism because, well, that's how you deliver a package. And then one power source, mine was a battery, one charging method, which I chose a charging port, and then one microcontroller, which I made it to be a Pi or like a Raspberry Pi, or a just general circuit board, then a propulsion system and a structural frame. So step one was to do the mind mapping. I did go a good deal overboard with the amount of ideas that I had. Had a hard time narrowing down what I wanted. Uh, but on top of that, I had a hard time even getting all of it into one picture to be able to turn in. Um, I do tend to get a little overexcited with ideas and come up with a few too many and not quite think about all the practicalities of it. Uh, I had fun with it though. Uh, when it comes to 3D modeling and design and stuff, I do tend to enjoy the organic type of modeling and ideas. So you'll see that quite a few of them were like my doggy drone, the Wally type, the believe in the water one. I had a shark, yep, an octopus, a lapras, which is a type of Pokemon, a giant monster. Um, I design idea is one that I had, which honestly would have been really fun as well, though that would have been so many pieces. Uh, so, and then from here we go to part two, which is our sketches, or my sketches, because I'm a team of one. This part was actually surprisingly the most difficult for me. None of my engineering classes or anything before this had ever taught me about how to do proper engineering sketches or anything to do with connecting parts and stuff like that. So when I went back to these for my next parts, it actually ended up being needing to be redesigned or adding a lot of more minor pieces. Um, but the ideas I had were the Wally type, so my square, which was a land drone, Roomba like one, uh, the air travel mechanism. That one, I think I chose to have ion thrusters just for the silly idea of that being a possibility. Um, when I did research on cost for that, I realized that that was about $20,000. So I kind of dropped that idea. Um, and then my third one, which was my favorite, was because it was the most organic looking, was the manta ray idea, which is a submarine type. So next we get into choosing which design. And with this new image here, I did do a near complete redesign of my manta ray manta ray water drone. Uh, so I still didn't grasp everything until I got to actually creating the whole design, but this definitely filled in a lot of pieces that I didn't have from the previous step. And then for the decision making criteria itself, I the options all gave me a oh, the Wally or Square Land one is going to be the most cost effective and just best out of, all the criteria. So that was the choice. Were this anything outside of learning how to model and design things? So in the end, I was able to actually choose my favorite one, which is the manta ray water drone design. Then we got to creating it. This I did get started fairly early, and yet I still managed to have to go late into the final day. I think I turned it in with 2 hours left because I ran into quite a few of bugs. In fact, two pieces actually got corrupted, and I had to work with my professor, our professor, because that's everyone who's going to actually be listening or watching this video, um, to make sure that we were even able, or I was even able to finish the project and be able to turn it in. Um, I did end up going quite a bit overboard with this section. Um, I started having too much fun with it, and then by the end, I was sinking way too much time into it as well. But honestly, it was fun. It was a really good learning experience. This is also the part that in my opinion, I learned the most in. There was a lot of, oh, how am I going to make this? Or especially these wings. I had to figure out how to fully define not splices, uh, splines, the really annoying to fully define one, um, to get everything and make sure it was all fully defined. Um, then the delivery system was probably the most difficult part of it for me because everything else I had a fun idea, rough idea of what I was doing. I knew what a circuit board being connected to a shell or chassis or case looked like. Um, I knew what fans looked like, but a delivery mechanism I hadn't really done so much of before. So that was quite the learning experience. And then also, learned a lot of the mates, the more advanced mates, like the hinges, or, well, mostly the hinges, but also the stuff like the rack and pinion or the gear belt, that sort of thing. Uh, Took a lot of time to learn, but honestly, I even if part of it was driving me up an entire wall, I enjoyed it and learned a lot. So next would be the motion part of this. Um, so we've got a few images here of what my project eventually looked like with all the components interacting with each other. Um, in this first one, top left, we've I have it showing off the belt, uh, the three belt mechanism for the propulsion fans. Uh, I've got the main motor in the middle here, and then it's pretty symmetrically lined up to run them both the same way as it gets spinning. So it's one motor for my steering. Uh, the second one here, the side view on the right side, is just more showing of like the different belts that I used. So there's this steering one up here. This one in on the bottom of this picture is the delivery mechanism. What happens with this is, and the delivery mechanism outside of the motor and belt is actually the bottom two pictures as well. So we've got, as this gets pulled for like pushed forward from the motor with the belt, it opens the front door and pushes out the delivery package. As it keeps going, there is a part on the part that mounts it to the chassis that pushes down this extender piece so that it actually can push all the way out for someone to be able to take off of the drone and properly deliver it. Uh, and then, of course, we've got movement for both the back door and the front door. This back door here is to allow for access to things like the battery, the back motor, the pie, you know, brain of the operation, and then kind of all the back pieces to this drone that would not be really easily accessible from the front because it is that large. Uh, I also learned that there are certain aspects of the hinge mate that will not allow you to move it. Well, it allows you to move it, but what happens is if you move it, suddenly, if you have anything that is based around like an in place mate or in place sketch, anything that references the original, like in my case, it'd be my chassis. If I moved that door up, things would just get crazy out of place and just not work anymore. So if you have hinges or anything that's going to like go up or down or like rotate 180 or honestly even just 90 degrees or 45, uh it should not be linked to anything else other than anything that is staying on the same exact level as itself. So that was a fun and interesting 3 hours of troubleshooting that one. Uh, so yeah, no, this one was, I learned a lot. I sunk a lot of time into it, and it did corrupt right before, like, I think it was something like 4 or 5 days before I was going to turn it in. So that was a mad dash to figure out how to get that to, well, work properly. So now we come to the assembly drawings. Um, I, because my design was pretty large, I actually ended up with, I think it was 147 individual components, but that's like including all the screws, all the multiples of things, all that sort of idea. Um, and I also came across an issue where the I had three of the same part that were all in different compositions. Um, and anytime I would try to load them in after saving as the correct type, it would just all load to the same type again. No idea what is causing that or what did cause that. And in fact, I believe that was a major contribution to one of my parts, my belt parts, saying that, oh, I'm fully defined, and or fixed. I'm fully fixed. So I can't move, except I would move it and everything would move as it should. So that was a weird thing. Um, Either way, it was working in the end. But yeah, no, strange thing. Uh, because my bill of materials ended up being pretty large, I wasn't even able to put the expanded view or exploded view on the same page as it, because there would be no way to see any of the minor details or what the arrows are even pointing to if it were on the same page. So I put it on two different pages and kept the first page to just showing off, hey, this is what it looks like put together. This is when I've got most of the components that can move fully extended in the spots that it would extend to. And then page two would be all of the bomb balloons and all that fun. Then it came to the individual drawings. Uh, because of the issues that I had with the motor mounts, and that was the part that kept defaulting to the same configuration, it was so weird and still does. I don't know what's going on with it. I decided that that was going to be one of my drawings. I'm going to show what each piece is supposed to look like and, fully define it, all that fun jazz. Um, for my drawings. So it's this middle one here. Uh, and then for the other four, I chose slightly easier ones just because I put a lot of time into this three configuration drawing. So what I learned was that it can be very difficult to remember what you did to fully define the piece in the when making the part and then translate that to your drawing. Um, like with this 10 and 5 on the three configuration motor mount drawing, those are the numbers they are supposed to be. And for some reason, when I was putting it together in the drawing, it kept showing as like 4.949 or something like that, and 9.5 3 or whatever. Uh, Close enough to 10 that I was like, this is a little weird. And then I opened up the original drawing and it's like, yep, this is 10, this is 5. Don't know why it's not showing correctly, but this is what it's supposed to be. So I fixed it to be corrected, which is why it's purple. Um, but that is this propulsion fan case was also a bit of a pain as well because I had it in a few specific views. The true isometric view, quote unquote, is supposed to be in like flipped 180, and then you couldn't see really anything about it other than the back of it, which doesn't really help someone who wants to make this from a drawing. So I had to figure out how to move that to the correct placement and then, adjust everything else to be able to see it the best way possible because it was not made to, I did not draw it or create the part to be particularly easy to figure out. Once I put it into a drawing. So remembering that for next time for sure. And then the bomb. I did not realize until the very end, and I will fully admit this and apologize for it. I did not notice that I needed the fabrication and cost of each piece until creating my PowerPoint for showing off what I needed to, or what I have gone through and learned from uh that total cost. The costing part of the evaluation in SolidWorks is pretty interesting. Um Made me realize also that my chassis is super large and costs way more than I expected. Even I chose like the least expensive piece that would actually keep some uh structural integrity because this is a submarine. It's going underwater. It needs to withstand that pressure. So it ended up being about $1,500. I Unless I wanted to change it to something with a lot less structural integrity or figure out a more advanced understanding of the costing, there was no way I could get it lower than that really. Um, and then went through the rest of it, did not realize how expensive this all was. I swapped between machining and casting and plastic, and even with that, this is an insanely high cost. And I'm definitely going to be keeping that in mind for my future builds because especially with like the chassis I would absolutely have to split up into like each side is its own piece. Even though that would lessen the structural integrity, the cost of it would be so much more reasonable on so many ways. So that's what I learned from the bomb in this one. And conclusion that yes, I learned a lot. Very generic. You're welcome. Um, with this project spanning the entire course, uh, my thoughts about the entire course kind of are incorporated into this conclusion as well. I learned a lot. I did not realize that there was so much that goes into CAD that isn't just the modeling part. Um, and I found myself to be pretty adept to 3D modeling. I've done 3D modeling before, but in a sculpting type, and I love 3D printing. Uh, and I'm pretty sure that my next job, if not my career, is going to be CAD drawing. Um, and of that, I know that surfaces was kind of more for the organic type of idea, but that's kind of what I enjoy the most with 3D modeling and that sort of thing. And I do seem to get ahead of myself when it comes to ideas. I used CAD to make a manta ray drone as my first ever project using CAD. So, and honestly, if I had known about surfaces, I would have used that for my wings, and that would have in for the manta ray, and that would have been so much easier. Figured it out, but this would have been so made it so much easier. Uh, I had fun. I thought that this was a really interesting project. Taught me a lot for sure. Uh, and honestly, I appreciate the project. It's 1000% going straight into my portfolio. Thank you very much to watching, listening to this. Uh, I hope you all have a fantastic winter break.